Hey, how's it going? So I was working on a project in my own personal life and this issue came up and I found it sort of hard to find an answer and I sort of had to work it out for myself. So I thought I would just make a quick little discussion on it. I've been working on a project which is using marching cubes to build a mesh based on an ISO surface. I'll just give this a spin. For part of the project, I'm also measuring the performance of the build process. So we have this sort of surface, which is an implicit surface, so it can be self-intersecting and things. If this was purely a function of position, height was a function of position, this would be very straightforward. Just plug it in, we get the height directly. But this is potentially circling over on itself and things. So what I'm doing at the moment is I'm building this on a compute shader. But then the issue is, in the compute shader, we need an atomic counter to measure the number of triangles which were built so that the threads don't interfere with each other when they're appending to that buffer. What I'm doing is I'm using an atomic counter, but that atomic counter also has to interact with the CPU because we need to, at the start of the frame before the mesh is built, clear the atomic counter off with a value of 0. And then at the end of building, we need to read back basically how many vertices were written, how many triangles were written, so that we can issue the draw call. Now, I know what you're saying. Hey, what about indirect draw calls, where we would, from the GPU, write the parameters to the draw call to another buffer and then run that without even touching the CPU? And the answer is yes, do that by all means. But as a little side note, I came up with this issue. So what I'm doing to try to speed things up is I'm using direct memory access. That is, we map to that buffer location and then mem copy over to that. We can see that if I just zoom in a little bit. We go ahead, we map to the buffer, we mem copy the value of 0 to the buffer, and then we unmap the buffer. Now, slight overkill here. Let me get rid of that, see if that works. So from the documentation, any of these operations will actually trigger that memory upload. Let me just try this. Yeah, works the same way. Great. But then the issue is, how do we pause the GPU so that it doesn't run until this mem copy has completed? Typically, we would use a memory barrier. That's what we're actually doing down here. We go, okay, run the compute shader and then insert a memory barrier. But the issue is that the memory barrier is for work which is currently going on all in one spot. So it's all happening on the GPU. So the GPU does its compute shader thing and then it sees the barrier and it stops, and that pauses it before any other OpenGL operations happen. However, this mem copy was initiated from the client side, from the CPU, and so the GPU just doesn't know about it. And that is the purpose of this fence. And I was sort of shocked when I saw this to learn that OpenGL has fences, but here they are, and here's how you use them. So we create a fence synchronization object, and these parameters here, I've checked in the documentation, they have to be these ones. That's just it. This returns what's called a GL sync object, GL synchronization object. Okay, great. And then we have to wait on that. Now, there are two types of waiting. There's wait sync and client wait sync. So in this case, I want the GPU to wait, which is why I insert this synchronization. At this point, we'll time out after 1 second. At this point, the GPU will pause until that mem copy is complete. And then similarly, we go ahead, we build the mesh, but then before we read back the value of the atomic counter, we need to make sure that the compute shader is done. Now, again, does this not synchronize? Well, the answer is it does, but it only synchronizes between OpenGL operations. Just because I've run dispatch compute and then run barrier, that does not mean on the CPU side that the CPU is going to stop until after the compute shader has done its thing. It's an asynchronous operation, Any GL stuff I put here will pause until that compute shader finishes, but client-side stuff is not necessarily going to pause. So that's why I'm doing this synchronization here. So again, I do the thing, and then I want to wait until the GPU is finished, and I want the client to wait. I want the CPU to wait until the GPU signals that it's done. And then at that point, I can copy the memory. I'm all good. And as a matter of fact, this client wait is an even stricter barrier than a barrier. So I can actually remove that barrier because the CPU is going to wait for the GPU to be done. And it's the same performance. But I do think that inserting a memory barrier is best practice. And I think there's nothing wrong with being super secure. But anyway, look, I just wanted to go through that. I'm not going to be providing code for this because it's just a quick throwaway thing. Yeah, let me know if you have any questions. But I think it's super cool because this is sort of revealing some of the boundaries between OpenGL and Vulkan. Like if we look at this barrier, as per the documentations, we need to put these options in. But this was written being sort of future-proof. Like at a future point, if they developed, I guess, OpenGL 4.8 or something, they were going to come up with more options for fences. It highlights how much better Vulkan is, because with Vulkan, you can wait on more granular operations. And instead of waiting for everything on the GPU to complete, you can have a Vulkan function signal a specific fence. And I just thought that was cool. That was my everything coming together moment. And I just wanted to share it. Anyway, all the best. I hope you enjoyed this and keep coding. Bye.